Find the remainder when 3 power 21 is divided by 5. So, the question is like this: 3 power 21 is divided by 5. What is the remainder? Okay. So, here when it is divided by 5, the units place will decide whether it gets divisible or not. If the units place is 0 or 5, then the remainder is 0. If units place is not 0 or 5, then the remainder is decided by the units place that is available here. So, in order to solve this problem, first find what is units place for this number 3 power 21. So, 3 power 21 we can write in the 4 multiples like 4 5s are 20 plus 1. As I told you, it gets repeated for every 4 multiple. So, units place of 3 power 21 is equal to units place of 4 into 5 plus 1 is equal to units place of 3 power 1. This is based on units digit. So, it means that the units digit of this 3 power 21 is 3 here. So, now it also means that for this question the remainder in units place is 3 and it is divided by 5. So, obviously the remainder will be equal to 3 here. Okay. That is how we will solve this problem. Now, moving to next problem. So, when a number n is divisible by 5, the remainder is 2. What is the remainder when n square is divided by 5? Yes. We can interpret this question as when n is divided by 5. So, this dividend by divisor will have to know this quotient remainder divided by divisor, and they are saying that remainder is 2 here, that is quotient 2 divided by 5. What is the remainder when n square is divided by? So, n square means here we are squaring it. It means that this side also we have to square it. Okay. So, square it. So, now it becomes n by 5 whole square is equal to q 2 by 5 whole square. If I separate it, it becomes q square, okay, plus 2 into q into 2 by 5 plus 2 by 5 whole square. So, it looks like, so the remainder got squared when the dividend got squared. So, the remainder for n square is, now it became 4. Fine. This is an important question. If sum of digits of any integer between 100 and 1000 is subtracted from same integer. Yeah, nice question. So, let me take some 3-digit number above 100 less than 1000. Let me call it as x, y, z. And the value of this x, y, z is, it is in hundreds place x is there, 100 into x, tens place y is there, 10 into y, and units place you have z here. It becomes 100x plus 10y plus z. This is the integer, and sum of digits of any integer. So, for this, if you take sum of digits, it is equal to x plus y plus z. Now, if this sum of digits got subtracted from this integer, so that is what the question gave. So, that is 100x plus 10y plus z is subtracted with x plus y plus z. You will get here 99x plus 9y. So, if you take 9 common here, it becomes 11x plus y, and the resulting number is always divisible. This number, the resulting number is always divisible by 9. Yes. So, the answer is 9. They gave the question like, so 4 to the power of 61 plus 4 to the power of 62 plus 4 to the power of 63 is always divisible by. So, in order to find out what is the number that is always divisible, this number. So, if you see it, these 3 numbers, these are in high power of 4. So, we cannot find this value. So, to avoid finding the value, let us take common in this 3. What is the common here? 4 is common and 4 to the power of 61 is common here. So, as you have taken out 4 to the power 61 here, only left behind is only 1 here. Now, similarly here, if you take it here, you will be left with only 4 here. If you will take 4 to the power 61 here, only left one is 4 square here. So 4 power 61, you will have 1 plus 4 square means 16. So it is equal to 4 power 61 into 21. So this 21 is exactly divisible by 21 by 21. If you have the options 7 or 3, there are also answers for this 7 or 3, because 7 can be divisible, 21 is divisible by 7, and 3 also, 21 is divisible by 3 also. So either the answer, final accurate answer is 21, the other answers may be 7 or 3. So all these 3 are right. Now, so the last number which must be added to a greatest number of 4 digits in order that sum may be exactly divisible by 307. So we know that the last 4 digit number is 9999, and it has to be exactly divisible by 307. So divide it with 307. Okay, 307 3s, you will get 21, 9. So you will get 9, remainder as 8, 7, 89. Now again divide it with 7 2s, yes, 3 means it will cross it, so 2s, then it becomes 2 7 14, 2 3 6. So it is 9 minus 5, 5, 7, 1. 175 is extra here. Otherwise, if this extra is not there, it gets divisible and remainder is 0. And the question is, the last number which must be added to the greatest number of 4 digits in order to that the sum may be exactly divisible by 307. So in order to divide this sum, the 4 digit number, exactly how much we have to add, as the divisor is 307, the remainder is 175. So the number that has to be added is 307 minus 175. It becomes 125 plus 7, which is equal to 132. So if we add 132 to 19999, then it becomes 129. This is the greatest number when divisible by 307, the remainder is 0. The first question is, which of the following fraction is the smallest? Okay, so we required smallest one. So this can be solved in three methods. That is, first method is so comparison, like make all denominators same. Here denominators are different. So in order to make the denominators same, take LCM, 6957 LCM. Okay. And this LCM value is 3 into 2 into 3 into 5 into 7, which is equal to 18 into 35, that is 700 minus 70, which is equal to 630. So we have to make all the denominators as 630, so that we have to multiply by 105 here to make it 630. So here it is 70, here it is 126, here it is 90. So now all denominators have become same, that is, it is 630 here, 630 here, 630 here, 630 here. Okay, the numerators, it is 105 into 7, it is 735, it is 490, it is 504, this is 450. So if we compare this numerator part, because we cannot consider this now denominators because all are same. Now if we compare only the numerator part, if you see it here, the smallest is this 450 here. So hence, as this numerator part of this 5 by 7 is the smallest, the answer for this is smallest is 5 by 7. This is the first method. We'll do one more method. Take these numbers as it is: 7 by 6, 7 by 9, 4 by 5, 7 by 9, 4 by 5, 5 by 7. Okay. So here the model is, in order to find smallest, first we'll compare among these two numbers which is smallest. Next, to this smallest we'll compare with this number, and among these two which is smallest, and the result we'll again compare with these two numbers, and finally we'll get smallest. So we can apply same concept for biggest also. We can first get biggest among these two numbers, then the result will be compared to next number, and the result is compared to again next number, then that is the final result. So if you compare between these two numbers, 7 by 6 and 7 by 9, whichever is the smallest. Now denominators are not same. So what we have to do is, not to make it same, I have to multiply 3 on this side and 2 here. So this becomes 21 by 18, this becomes 14 by 18. If you compare, as now denominators are same, now if you compare the numerators, this is smallest, hence 7 by 9 is smallest, and now this number has to be compared with next number, so 4 by 5 here. Among this, first make the denominators same. Now here 45, 45, so if you check it, numerator 7 5 is 35, here it is 4 9 is 36. Now among these two, this is smallest, 35, so that is 7 by 9 is smallest. And last, we are comparing between 7 by 9 and 5 by 7. Here it is 7, here it is 9, so it becomes denominator 63, 749 here, it is 545, it is 63 here, and 5 is 45 here. So we required the smallest, so the smallest is this one, so 45 by 63, hence the answer is 5 by 7, that is smallest. This is the second method. Now we will also see the third method here, that is approximation method. Okay, so let's approximate this 7 by 6 value. 7 by 6 value, it will be around 1 point, okay, so 1.6 something, okay, 1.1, sorry, 1.1 something. Now if we go to 7.9, it is approximately, so 9 7 is 63, 7 is 63, so it is approximately 0.7 something. Now 4 by 5, it is equal to 0.8 something. 5 by 7, which is equal to 0.71 something. Now obviously it is something 1.1, so this is not the option, and 0.8, this is not the option. Among these two, whichever is the smallest, if you compare them directly, then you will get the answer. So obviously this is smallest, 5 by 7. So through approximation also we can find out the smallest one. Now we'll move to next question. They have given that sum of two numbers is 40 and the product is 375. What will be the sum of their reciprocals? So given data, decode it as it is. Sum of two numbers, let the numbers were assumed as x and y, so they are 40, and the product is x into y, which is equal to 375, and try to write what you want. So what will be the sum of the reciprocals, that is 1 by x plus 1 by y, and try to see so do the calculation for this. So it becomes y plus x divided by xy. This is what you required, and already it's available, sum of numbers and product of the numbers. So substitute them, it is 40 by 375. If you do calculation, 5, So 5 8 ja 5 75 ja, it will be 8 by 75, option 1. Okay, so whenever the question is in this theory part, decode the question point wise. So like this, first decode first sum of two numbers as one equation, next equation product on next equation, and what you require, that is sum of this, so this one, and do some calculation, and from this question just check what all you required. So always if the question is bigger, we'll decode it like this. We'll write as we'll convert each line and we'll see what we want, and whether that what we want is available in our given data. We'll check it. If not, we'll see what are the formulas available to solve this. Okay, we'll move to next question. The question is, a 6-digit number is formed by repeating a 3-digit number. Okay, so 6-digit number is formed by repeating a 3-digit number. Example 256 256 or 678 678, etc. etc. means that we can apply this concept to any numbers. Now any number of this form is always divisible by dash. Okay, when any number is mentioned, we can take the simplest one and, for solving, rather than taking this difficult one. Simplest one is, we require this bit in order to get it is a 6-bit number. So first bit has to be there and remaining bits are optional. So as it has to be repeated, so let me make it like this. So 100, and as it has to be repeated, I'll make it one more 100. So this is my reference number. Okay, now for this reference number, so based on the value, if I write it, this is 10 units place, tens place, hundreds place, 1000, 10,000 and 1 lakhs. So 1 lakh is available, and this is not available, and next place is not available, and now hundreds place is 100 is there, and remaining are 0. So if you write it like, it becomes 1 lakh plus 100. So 100 is common in this, take it here, it becomes, as 2 zeros are left now, so remaining 3 zeros. Now as 100 is left, now it looks like 100 into 1001. Now among the options, if you check it, first option is whether it is divisible by 7 only. So try to do divisible by 7 and check it. So 100 is not divisible by 7, so no need to check it. Only 1001 has to be divisible by 7. So what is the divisible rule for 7? So remove this last unit digit and make the double of it and subtract it. That if the resultant is divisible by 7, then the given question is divisible by 7. Yes, 978 is divisible by 7, that is 1 4. So it is divisible by 7. Okay, so option 1 is true, but they have given here it is only. So we don't know whether it is only divisible by 7 or not. So let's check for other option. So 11 option. So 1001 divided by 11. So what is the divisible rule for 11? So sum of odd places is equal to sum of even places. So this is odd, this is even, this is odd, this is even. If you check it here, sum of even places is 1, sum of odd places is also 1. So which is equal to 1 is equal to 1. Hence this is also divisible by 11. So let me check the third option, that is 13. So 1001 is divisible by 13 or not. 13 7 ja 91, and here 91, 13 7 ja 91. Yes, it is also divisible by 13. And last option is, they didn't mention only here, they said it is divisible by 1001. Yes, it's clear, 1001 is here and it is obviously divisible by 1001. So as first three options also right, but as they mentioned there it is only, so we are not taking these three options, and the best option is fourth option, because we don't have only here, and this is 1001, hence the answer is D option here. Okay, fine. We'll move to next question. The question is, if 17 power 200 is divisible by 18, the remainder is. Okay. Normally whenever we get this remainder and powers form, first try to take this units digit and take this power rule and divide with this units digit of this, and check whether units digit whatever is the answer in units digit, and that might be your remainder. But when the number is high here. So doing that method will not give us confidence that this is the remaining one is the remainder. So let's go to another procedure. But here if you observe carefully, there is a 17 power 200 divided by 18. So there are nearest numbers. So I thought we can write it in the nearest form, that is 17 plus 1. So whenever we have numbers like this, 17 plus 1, so we can make here plus 1 and minus 1 here. So 1 power 200 also we can readjust like this. So it becomes 17 power 200 plus 1 power 200 divided by 17 plus 1 minus 1 divided by 17 plus 1. We know that a power m plus b power m is definitely divisible by a plus b. So here it looks like this, 17 power 200 plus, so it gets divisible here. So there is no problem here. So only problem here is this one has to be divisible by 17 plus 1. So this is not possible. This is not possible. Hence this will be left out, and that left one is nothing but remainder. Hence the remainder is 1 here. So this one will becomes remainder because this is not divisible. This gets easily divisible here. So whenever we have problems like this, so like a power n divided by like a plus 1 format, so a power n divided by a minus 1 concept, try to restructure the question and check it. So you will get the remainder easily. So if you want, I will give some conclusions here. A power n by a plus 1, if n is equal to E1, the remainder is 1. No need to by heart this, keep some value here, a square, give here a plus 1, add plus 1 minus 1, okay. Now if you observe it carefully, so this is fine. Even you can do this, minus 1 can be kept there, a square minus 1 plus 1 divided by a plus 1. So this a square minus 1 can be written as a minus 1 into a plus 1 whole divided by a plus 1 plus 1 by a plus 1. So this got cancelled, and so you have result of a minus 1, and only left here is 1, hence the remainder is 1 here. Now if n is odd, just take some value here, say a, so a power 1 divided by a plus 1. So as this number is lesser value compared to this a plus 1, so hence this will be left as a remainder here. So hence remainder is a. Okay. So for the other case, if a power n by a minus 1, is always divisible by a power n, hence the remainder is 1. You can remember these 3 cases. If you forgot this, just apply some numbers n, like n is equal to 1, 2, 3, and try to get the result. Now we will see 5th question here. The sum of all natural numbers between 100 and 200 is which are multiples of 3. Okay. He wants all natural numbers between 100 and 200, but the condition is they must be multiples of 3 here. So normally numbers will start from, sum of numbers will start from 100, 101 and so on to 200. So totally we will have around, so we will have 200 minus 100 plus 1, so 101 numbers between 100 to 200. Okay. So normally from 101 to 200 numbers, and 100 is involved here, so plus 1 has to be done. So we will have 101 numbers. But the condition is here, these numbers has to be multiples of 3. So multiples of 3 is, so we have to check whether this 100 is multiple of 3 or not. So divide this 100 divided by 3. So 3 is a 9, 10, 3 is a 9. So 1 is a remainder here. Hence this is not your multiple of 3. So check it for 101. This hence this also. So the number starts from 102. Okay. And to the end also check it whether this is multiple of 3 or not. 3 6 18, 3 6 18. So 2 is extra. So hence this is not your multiple of 3. Hence you have to remove that 2. It becomes last number is 198. Okay, this is divisible by multiple by 3. So the first number is 102 and last number is 198 here. Between the how many numbers are there? First divide this with 3. It becomes 3 3 and 3. starting with 34 multiple here. If you divide here 3 6 18 3 6 18. So starting from 34 multiple ending with 66 multiple, we have in between 100 to 200. So how many total number of 3 multiples are there? Is 66, okay, minus 34 and plus 1, because even this number has to be included, so we have to use plus 1 here. So this is equal to 32 plus 1, which is equal to 33. Now once how many total numbers are there, and you know this first number and last number, then and all numbers are multiples of 3. So it means that if sum of all numbers, if they are multiples of 3, the difference between each number is 3. So hence the difference is 3. It looks like everything is in arithmetic progression. So we can use the formula for sum of numbers in arithmetic progression is n by 2 into first number plus last number. We know this n value is 33 by 2 into first number is 102, last number is 198. The answer it becomes, okay, so it is 33 into 150, which is equal to 4950. Second option. Fine. Now sixth question is 800 chocolates were distributed among students of a class. Each student got twice as many chocolates as number of students in the class. Okay, the number of students in the class was, fine. So total number of chocolates available is 800. Okay, now each student got twice as many chocolates as the number of students here. So let number of students is equal to x here. So this number of students got number of chocolates is equal to, so it is twice as many chocolates as the number of students, that is 2 into x here. Therefore total chocolates is equal to, so number of students into number of chocolates, which is equal to 2x square. And they have given already this total number of chocolates is 800. So make this 2x square is equal to 800. So x square is equal to 400 and x is equal to 20. So this number of students in the class is 20 here. Okay, fine. When a number is divided by the question, when a number is divided by 56 here, the remainder obtained is 29. What will be the remainder when the number is divided by 8? Okay, fine. So the question is, let the number is n here, and when it got divided with 56 into some quotient here, you got remainder as 29. Now when the same number is divided by 8, same number, this n number is divided by 8. So if you divide n by 8 here, so it means that you have to divide by 8 this side also. What will be the remainder? So let's see whether this gets divisible easily or not. So 8 7 is 56. Yeah, it is getting divisible, hence the remainder doesn't come here from this part. Now only the remainder will be obtained only from this part. 29 divided by 8, the remainder is 8 3 is 24 and the remainder is 5 here. So the remainder here is 5 and here remainder is 0, and 0 plus 5, the remainder is completely 5 here. The answer is B option. Okay. Now moving to next question. So here the question is, find total number of prime factors for 25 whole to the power of 12 into 10 to the power of 7 into 14 power of 7. So here, in order to find this total number of prime factors, everything has to be in prime. So convert them to prime. So 5 into 5 whole to the power 12 into 5 into 2 whole to the power of 7 to 7 into 2 whole to the power of 7. So here 5 square, it is 5. How many 5s are here? Square, it is 24. One more 7 prime number 7 here. A number of 2's here is already 7, and from here one more 7. Now 7 power 7. So it is equal to 5 to the power of 31, 2 to the power of 14, and it is 7 power 7. So when they want total number of prime factors, number of prime factors are 31 plus 14 plus 7, so it is 52. Find units digit in the expansion of 2137 whole to the power of 754. So units digit will be decided only based on units place. Okay, so instead of writing this complete number, take only units digit of 7 power 754 and write the 754 in the multiple of 4, that is 754. So 4 1 ja 4, 35, 4 8 ja 32, 34, 4 8 ja 32, remainder is 2 here. So write it like this, 7 to the power of 188 into 4 plus 2. So as it gets repeated for every 4 multiple, so we don't require this. So 7 square, take this remainder part, that's enough. Now 7 square means 49. Now units digit place is 9 here. So the unit digit for whole this expression is also equal to units digit of 7 square, which is also equal to 9. So answer is 9 here. The smallest number of 5 digits exactly divisible by 476. So we require the smallest number that is exactly divisible by 476. So we don't know that exactly. So let us take the smallest number of 5 digits as 100000. Oh, they require 5 digits only, no? 1. So it is 10,000. This is the smallest number. And it has to divisible by 476. So first we will divide it. We will see whatever is the remainder. We will correct it. So this is 10000. Okay. We are dividing with 476. 476 2 it is 952. You got 480 here. 1 it is 476. You got remainder 4 here. So it means that when you divide this smallest number with 476, you got the remainder 4. But as it has to be exactly divisible, the remainder also has to be removed. So we cannot remove divide this. We cannot remove this remainder. Hence, what we will do is, so in order to get divisible by 476, we will add 472 to this number, so that it gets, so 472 plus 4, 476, it gets divisible easily here. So the smallest 5 digit number is not 10,000 because it is getting remainder 4. For this you have to add 472. In order to that it gets easily divisible by 476. It is equal to 10472. So option is here D. Now the product of two numbers is 9375. The quotient when larger one is divided by smaller is 15. The sum of numbers is 5. So let's decode the given question. The product of two numbers. So let us assume that the two numbers are x into y. So the product of two numbers is x into y is equal to 9375. Yes, first one. Next, the quotient when larger one is divided by smaller one is 15. So let me assume this x is greater than y here. So when this larger one is divided by smaller one, the quotient is 15 here. 15 here. So and it is divided by smaller one means it is exactly divisible here. So that is x can be written in the form of 15 into y, quotient into divisor. Okay. Now substitute this x value in this first equation. It becomes 15y into y is equal to 9375, which is equal to y square is equal to, so 9375 divided by 15, which is equal to 625. Now y square is equal to 625. So if you take y is equal to square root of 625, the answer is 25. So we got the value of y is equal to 25. If you substitute this y value here, you will get x value here, which is equal to, so this is 15 into 25. So 250 plus 125, which is equal to 375. You got x and you got y. The question here is the sum of these numbers is, sum of numbers means x plus y, which is equal to 375 plus 25, which is equal to 400. Let's move to next question. The question is 2 power 16 minus 1 is divisible by. Okay, so it's like a power n minus 1 is definitely divisible by. So 2 power 16 now we can write like this: 2 power 8 whole square minus 1 power 8 whole square. So a square minus b square format, so we can write it like a minus b into a plus b, that is 2 power 8 minus 1 into 2 power 8 plus 1. Even this number we can correct it: 2 4 whole square minus 1 whole square into 2 power 8 plus 1. So which is equal to 2 square means 2 power 4 minus 1 into 2 power 4 plus 1, which is 2 power 8 plus 1. Now this 2 power 4 minus 1 again can be written as 2 whole square minus 1 into 2 power 4 plus 1 into 2 power 8 plus 1. So this can be written as 2 square minus 1 into 2 square plus 1. Sorry, 2 power 4, right? 2 power means 2 square. 2 square means 2 minus 1 into 2 plus 1. 2 power 4 plus 1 by 2 power 8. So this complete number can be either divisible by 1, divisible by 3, divisible by 17, divisible by 65. So if among these options, so 11, 13, 17 and 17 here, we have 17 here. So it gets divisible by 17 here. Okay, so answer is A and B are odd numbers. Then which of the following is even number? This is very simplest question. If A and B are odd numbers, then which of the following is even? So they have given that A and B are odd. So let me take A value as 3 here, B value as 5 here, and substitute these two values in the given options, and whatever is giving the even value, that option is right. Substitute it here, it becomes 3 plus 5, first option, A option, divided 15, which is equal to 8 plus 15, which is equal to 23, hence this is not. Substitute here, 3 plus 5, 8 minus 1, which is 7, this is not even number. 3 plus 5 plus 1, which is 9, this is not even number. Now here 3 plus 5 into 2 into 3 into 5, which is equal to 8 plus 30, it is equal to 38, which is even number, hence the option 4 is correct. Now the decimal fraction of 2349 is 2.349 bar is. Okay, so in order to find this decimal fraction, first separate it. Separate these two numbers separately and decimal part separately, that is 0.349. As it is a recurring digit, we have the logic for this. So recurring is converted into fraction part by taking complete number minus non-recurring digit divided by 9s for number of recurring digits, 0 for number of non-recurring digits. So this is the answer. 2 plus 346 divided by 990. Multiply here 990 into 2. So it is 1980 plus 346 divided by 990. So only 20 is short here. Give it 20 here. It becomes 2000, and 20 is short here. 326. So 2326 divided by 990. So among these options, this second option is suiting here. Two numbers 11284 and 7655 when divided by certain number of 3 digits leaves same remainder. The number of digits of such 3 digit form is. Okay, we have one number 11284, one more number 7655. When divided by certain number of 3 digits number, we don't know that 3 digits number. Let me call it as ABC. So when these numbers are divided by same ABC, leaves same remainder. So same remainder means something remainder as R. The sum of digits of such a 3 digit number is. Okay. So maybe if we divide this number with ABC, we'll get a quotient say P, and we got remainder R here. For this number again 7655, if you divide with ABC with Q, you will get same remainder R here. Subtract these two numbers, it becomes 11284 minus 7655, which is equal to ABC into P into Q. So P minus Q, and this remainder get cancelled. So you don't have anything here. So if you separate 11284 minus 7655, this becomes 3629. Okay, and this is equal to two numbers a, b, c into some number of p minus q. Okay, and it has to be a 3-digit number, and so one number has to be 3-digit, and I don't know that number exactly, and that's a multiple of one more number. So first take the factors for this 3629. Okay, so if you observe it carefully, so it is so not multiple by 2, 3, 4, 5 anything. So let's take a 19 here, 19 1 ja 19, you will get 71 72 here, 19 9 ja 171, and 1 9 here, 19 1 ja 19. So it is equal to 191 into 19, this number 3629 is written as 191. This should be equal to ABC into P minus Q, and they said this ABC number is a 3-digit number. If you compare these two numbers, only 191 is the 3-digit number. So hence the answer is, the answer of which the sum the 3-digit number is 191. But the question is not this one. What is they asking? The sum of digits. So 1 plus 9 plus 1, which is equal to 11. So option 4, which is giving this result. Sum of digits of any integer lying between 100 and 1000 is subtracted from the number. The result is always. So this is an easy question. Already we have covered this question in previous examples. So let me take exam 3-digit number between 100 and 1000 as x, y, z. Okay, if you write this value of this x, y, z, it becomes 100x plus 10y plus z, and sum of digits of any integer, this integer is subtracted here. So sum of digits will be nothing but x plus y plus z, and it has to be subtracted here from this number. The result is here 99x plus 9y, and z get cancelled. So this is always divisible by, take 9 here common here, it becomes 11x plus y. So it is always divisible by 9 here. Fine. A rational number between 3 by 4 and 3 by 8 is, okay, 3 by 4 and 3 by 8 is between this. So first find out the value of this one exactly. 3 by 4 means it is 0.75, 3 by 8 means it becomes point. So it so 8 to 8, 3 is 24, 6, 8 7 is 56, and so on. Okay, between 0.75 and 0.37. This is the, if you convert to decimal, you will get these values. Let me check this, whether this value, what about this ratio number 7 by 9? 7 by 9 is nothing but point 7 means 7 9 and 7 is 63. Okay, and remainder is 7 9 7, so it will be 0.77. It is again, it is 2 point something, no need to write this. If you check it here, 5 by 9, it is 0.5 and so on, and here again it's 1 plus something, no, so it is always greater than 1. So we required a rational number between this 0.3 to 0.75, hence this is not one, and it is crossing 0.75, so hence this is not one, and it is 2 here, it is not one, so only left over is this 5 by 9. So the rational number between this 2 is 5 by 9. Fine. The greatest number among 3 power 50, 4 power 40, 5 power 30, 6 power 20. Okay, so in order to find this greatest number of these 4 numbers, so either this base part has to be same or this powers has to be same. So we clearly know that we cannot make this base part same, because 3 4 5 6 we cannot make it. So only thing we can adjust is, we can adjust this powers. So let me adjust this powers. It becomes 3 power 5 whole power 10 here, 4 power 4 whole power 10 here, 5 power 3 whole power 10 here, 6 power 2 whole power 10 here. So now all powers are same. Now we can compare easily. 3 power 5, it will give you 243, 4 power 4 256, 5 power 3 125, 6 square it is 36. Among these 4 numbers, which is greatest? So 256 is greatest, hence answer is 4 power 40. So if you observe these options, we don't have 4 power 40 here, so correct, write it in the fourth option, 4 power 40, and this is your correct answer. Find the least number which must be subtracted from 18265 to make it perfect square. So let me check whether this number is perfect square or not. How to check it? By finding square root for this problem. So we'll try to find square root for this problem with the help of division method. Okay, so pair two numbers from the last digit. So 65 is paired, 82 is paired, and one number. So in order to get this number, 1 ja 1. Okay, so now next two numbers. So this 1 has to be added here. Now this is 2 here, and here if you keep it here, 23 3s are, it becomes 69. You'll get remainder as 13 here. Bring this 65 again. So add this 3 here. It becomes 26. And which number you have to keep it here? Keep 5 here. It becomes 1325. We have shortage of 40 here. So shortage, no, it's not shortage, it is extra. So if you remove this extra number, then in this given number, then this number becomes perfect square, and the square root of this problem is 135. Okay, first and the question is same, find the least number which must be subtracted, and this 40 must be subtracted. So hence answer is option C. Let's move to next question. The real number is to be added to 13851 to get a number which is divisible by 87. So we have to get a real number that has to be divisible exactly by 87. And in the question itself they are saying that what number has to be added to this. It is an indication that this number is not divisible by 87. Okay, let's go further in detail. First try to divide it with 87. 87 1 ja 87. We'll get remainder as 51 here. Bring this 5 here. 81 5 ja, it is 435, and the remainder is 80. I bring this one here. 81 9 ja, it is 783. We get the remainder as 18 here. This is extra number. If you subtract this number, subtract a number, then from this number, then this number has to will be divisible by itself. But what number must be added? So what number if you add it here, then it gets divisible by exactly by 87. So as 87 is our divisor. So in order to come to 87, we have to subtract this 18. It will give you 69. So if you add 69 here, then this number will be 87, and it gets divisible easily by 87. So the answer here is 69. That is the number you have to add to this 13851. Now let's see this question. The sum of squares of three positive numbers is 323. If sum of squares of two numbers is twice the third, their product is. Okay, so let's decode the given question with some variables. Sum of squares of three positive numbers. So they didn't say it consecutive positive numbers, hence we cannot take n minus 1, n plus 1. We have to take different positive consecutive different positive numbers. Say I call it as A, B, C. Sum of squares of this numbers is 320. Squares of this one is 323. Now if sum of squares of two numbers, so let me take these two numbers, square plus b square, it is equal to twice the third. So they have given a square plus b square is equal to 2c. So substitute this 2c here, it becomes 2c plus c square is equal to 323. So c square plus 2c minus 323. So you can find using it's a quadratic equation. You can find the root here. C is equal to minus d plus or minus square root of b square is 4 plus 4 into 323 whole divided by 2. It will give you minus 2 plus or minus root of 1 2, okay, 1289 whole divided, 1256 whole divided by 2, which is equal to minus 2 plus or minus 36 by 2. So we'll take only positive value, it becomes 17 here. So hence the c value is 17 here, but they said is it's a square plus b square plus c square is equal to 323. Okay. Now if you substitute c is equal to 17 here, it becomes a square plus b square is equal to b square plus 17 square is equal to 323. 17 square means 289. If you subtract here, so 289 here, it becomes this 23 plus it is 34. That is a square plus b square is equal to 34. And they didn't give any extra information here in how to find a and b. So hence we have to do here prediction method. So take some number whole square plus some number whole square, it is 34. So we know that 1 square is equal to 1, 2 square 4, 9, 16, 25. Okay, just try to add these numbers. Add this one, 25 plus 16 is 44. So add with this number 25 plus 9, it is 34. Yes. So if you substitute here 25 plus 9 is equal to 34. So a value is 5 here, b value is 3 here, and c value is 17 here. And the question is product of these numbers, that is a into b into c, which is equal to 5 into 3 into 17. So 5 is a 15 into 17, which is equal to 225 plus 30, which is equal to 255. This is the final answer. And we didn't give these answers correctly in options, so hence don't search in options. So the answer here is 255. Now, a number when divided by sum of 355 and 455 gives 2 times the difference as quotient and 30 as a remainder, and the number is fine. If we read it like this, the question looks very difficult. So just cut short. A number when divided by sum of these two. What is sum of this? 355 plus 55. 355 plus 445 is, it is 560. It is equal to 1000. A number n when divided by 1000. Okay, it gives the difference as coefficient. What is the difference? 2 times the difference. The difference is 355 minus 45. Difference is 110. So 2 times the difference as quotient. This is your quotient, and 30 as your remainder. 30 as your remainder, and divided by divisor. Divisor is 1000. So it is n by 1000 is equal to 220 plus 30 by 1000. The number is, so it is very easy to find out this number. N, in order to get this n is equal to 220 into 1000 plus 30. So which is equal to, so 3 zeros added here, it is 2,20,000 plus 30. So it is 2,0030. 2200, this one. Fine. Let's move to last question. An expression 8 power n minus 4 power n, where n is a natural number, is always divisible by. So in order to get always divisible, it's a natural number. They said n is a natural number. Substitute n is equal to 1, 2, 3, 4 and cross check with your options. So whatever number it is get divisible easily, and that is always divisible here. Just when n is equal to 1, 8 minus 4, n is equal to 1. So here 4 is divisible by either 2 or 4. So and that option is not here. So remove this. Substitute n is equal to 2 here. So 8 square minus 4 square. It is 64 minus 16. So which is equal to 48. 48 can be always divisible by, take a 15. No, it is not 15. 18. No. And 36 is okay. Yeah, it's divisible. Not exactly. Yeah, it is divisible. And 48 is far better than this. So hence we always go with higher one, that is 48. 48 is divisible by 48 here. Okay. So with this we have completed all the types of questions in number systems. So most probably the number system problems are interlinked to other topics like HCF, LCM and squares and simplifications, algebra and all. So we'll see more types of these number systems when we are discussing in other topics. Okay. Hope you enjoyed this class. Thank you.